Understanding linear functions helps you make sense of patterns and predictions in the real world, such as tracking phone data usage, comparing the cost of different streaming plans, or measuring how far you travel over time. In this lesson, you will learn terms for describing, reading, and modeling relationships using functions so you can understand how one quantity affects another. These skills are the foundation of algebra, science, and many real-life decisions. Before we can model or graph anything, we need to understand how inputs and outputs relate. These ideas help you describe how one quantity depends on another. Relation. Any pairing of inputs and outputs. For example, the set 0.12, the 0.24, and the 0.36 is a relation. Function. A rule that pairs each input with exactly one output. The set, the 0.12, the 0.23, and the 0.34 is a function, while the set, the 0.12, the 0.13, and the 0.14 is not. Domain. The set of all possible input values. For example, if a function uses the days of the week as inputs, the domain is the set Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Range. The range is the set of all possible output values that come from the inputs. For example, a function that outputs the temperatures for each day may have a range of the set 72, 75, 78, and 80. Independent variable. The value you choose or control. For example, in a formula for distance over time, time is the independent variable. Dependent variable. The dependent variable is the value that changes based on the input. For example, in distance over time, distance is the dependent variable. Functions can be written in different ways, and each format tells you something useful. These notations help you communicate clearly in math, science, and technology. Function notation. Function notation uses symbols like f of x to show how inputs connect to outputs. For example, f of x equals 3x plus 2 means the output is 3 times the input plus 2. Set notation. Set notation uses curly braces to show elements of a domain or range. For example, domain is the set 1, 2, 3, 4, and 5. Interval notation. Shows interval numbers using parentheses and brackets. For example, open bracket 0, 5, close parenthesis, means all numbers from 0 to 5, including 0, but not 5. A bracket is used to include a number, while a parenthesis indicates a number is not included. Some functions use every possible value in a range, while others only use specific separate values. Knowing the difference helps you choose the right model for real-life situations. Continuous. A continuous function uses all values in an interval and often forms a smooth line. For example, time and temperature relationships. Discrete. A discrete function only uses separate, distinct input values. For example, a table of number of tickets sold each day. Different types of functions create different shapes and patterns. Recognizing these helps you understand, predict, and compare real-world situations. Parent functions. The simplest examples of each type of function and act as the base shape. For example, the parent linear function is f of x equals x. Linear function. A linear function creates a straight line graph and changes at a constant rate. For example, f of x equals 2x plus 5. Nonlinear functions. A nonlinear function does not create a straight line and does not change at a constant rate. For example, f of x equals x squared. Some linear relationships appear as sequences instead of graphs. These help show linear patterns in situations that change step by step. Arithmetic sequence. An arithmetic sequence increases or decreases by the same amount each step. For example, take the sequence 5, 8, 11, 14. We are adding 3 each time.